All right, let's take a look at how to solve a differential equation given the initial condition that y of 0 is -2. So the first thing that we need to do is we need to do what we call separate the variables. That means we've got to get all the y's on one side of the equation and all the x's on the other side. So I'm going to multiply both sides by dx to begin with. And then I'm going to divide by the y so that I can have all the y's on this left side. And once I've separated the variables, now I'm ready to go ahead and integrate both sides. So I'm going to integrate the left side, integrate the right side separately. So the left side, the integral of 1 over y dy would be the ln of y. And the integral of x squared would be, we're going to increase that power by 1, put that new power under 1 on in front of the variable. Okay, so here I have it, and before I do this, I like to get the y by itself. So in order to get the ln off of the y, I'm going to raise both sides as exponents to the e power. I'm going to think of it like that. So the e and the natural log will cancel each other out, giving us y equals. Now over here, it looks kind of complicated, but I want to simplify it a little bit. So I need you to think back to when we add exponents, we were actually multiplying the bases. So I've got e to the constant times e to the 1/3 x cubed. So many times you'll see it written with as a big constant because e is a number to a constant is still going to be a number. Now that I've solved the differential equation, I'm ready to use my initial condition, which is that when x is 0, y is -2. So let's place those values inside of the equation that I've integrated. So y would be -2 when x is 0. So I've got 0 to the third is 0 times 1/3 is still 0. So I've got e to the 0, which we know is 1. That lets us know that that constant is -2. Now our final answer, we're going to take that -2 and place it in place of that constant in my equation to get my final answer here. I hope that helps.